Hey there, welcome to our video. What we're going to do today is we're going to see how do we find the sum of a geometric sequence. You may recall from our last video that a geometric sequence is just an ordered list of numbers where we find the next term by multiplying by something called a common ratio. In order for it to be a geometric sequence, you must multiply by a number. In example 2, what we said was even though it looks like division, what actually happened was we were multiplying by a half. So we need to remember for a geometric sequence, the common ratio is always written in terms of multiplication. And of course we had this formula here to find the nth term of a geometric sequence. Here, a1 is the first term and the common ratio is r. Today what we're going to want to do is find the sum of a sequence. So imagine we took example 1 here, and I wanted to find the sum of, let's say, the first 7 terms. That would really mean just to add all of these individual terms here, but of course we're going to want to do this more mathematically with a formula so that we can do it for more complicated examples. Let's take a look at what this formula looks like for a geometric sequence. This formula here defines the sum of a finite geometric series, meaning something that doesn't go on forever, something that has a finite amount of terms. The formula looks like this. The sum of n terms equals the first term times this product here. This product in the numerator is 1 minus the common ratio to the nth power, where n is the number of terms, divided by 1 minus the common ratio. Let's see if we can find a sum of a geometric series using this formula. In this first example, I want to evaluate this summation notation here, and I should realize here that this is a geometric series based on the way that this rule is written. If you think about the formula for a geometric series, it looks like this. And if you look, they are strangely familiar, except here instead of using n, I used k, which was the index down here. So that should be fine. So I can really see that this here is a geometric series. If it's a geometric series, well, I can use this formula here to find the sum of all the terms. I just need to plug in the first term, the common ratio, and how many terms we're looking at. Well, here it's going to be really easy to figure out what the first term is. I can see what's in place of the first term here is 4. What's in place of the common ratio is 3. And now I just have to figure out how many terms I'm dealing with. Well, we know if it's written in summation notation, there's a formula that says if you take the upper limit, subtract the lower limit, and add 1, you can find how many terms. That's exactly what we're going to do here. What we're going to do is we're going to take the upper limit, 16, minus 1 is 15, plus 1 means there's 16 terms here. Now all we want to do is plug in. For a sub 1, the first term, I'll plug in 4. The common ratio here and here, I'll plug in 3. And for the number of terms, I'm going to plug in 16. When I go to compute this, it can be a lot to deal with at first, so what I really like to do is simplify the numerator, simplify the denominator, then take care of this division, and eventually the product. Well, when I simplify the numerators, I should get this here. Here I'm going to divide the numerator by the denominator and multiply by 4, and I can see the sum of this geometric series is 86,093,440. Let's see if you guys can find the sum of a geometric series written in summation notation. Here in number 2, evaluate this series written in summation notation. Let's see how you did. This is clearly written in geometric form, so this is a geometric series, meaning I can use this formula here for the sum of a geometric sequence. First thing I want to find is a1. 5 is in the position as the first term, so 5 is the first term, a subscript 1. 2 is in the position as if it's the ratio, so the common ratio here is 2. And now I need to find the number of terms. To find the number of terms when we have summation notation, I take the upper limit, subtract the lower limit, add 1. When I do that here, I can see I have 10 terms. To evaluate it, I'm going to plug in. Plugging in would give me this expression. Next step, simplify the numerator, simplify the denominator. If I simplify the numerator, I get negative 1,023. If I simplify the denominator, I get negative 1. Take care of this division, I'll get 1,023. Multiply that by 5. The sum of this geometric series is 5,115. Let's try another example. Example number 3 is a little bit different because I presented the series here not written with summation notation. See if you can find the sum of the first 8 terms of this series. Let's see how you did. I can see that this is a geometric series. If I look here, I'm taking 3 and I'm multiplying it by -4 to get -12. -12 by -4 gives me 48. 48 times -4, -192. So this here is clearly a geometric series because it has a common ratio of -4. The first term here is clearly 3. Now all I have to do is figure out how many terms. Well, it's pretty easy to see that they said find the sum of the first 8 terms, so n must be 8. Because it's a geometric series, I can use this formula. For a1, the first term, I'll plug in 3. Common ratio, I'll plug in -4. And for the number of terms, 8. Simplify the numerator and simplify the denominator. After I've done that, take care of this division here, and then after we take care of the division, multiply by 3. I can see that the sum of the first 8 terms of this series is choice 3, -39,321. Let's try one last example. In this last example, number 4, I want you to evaluate this series here. Let's see how you did. I can tell this is a geometric series by the way it's written with this variable as the exponent. So I'm going to use this formula here for the sum of a geometric series. Here I can see that a1 is 12 as it's in the position where the first term is. The common ratio here is -1/2. I'm going to keep everything as a fraction. If you want to change it to a decimal, you're welcome to do that. Need to figure out how many terms. If I have a series written with summation notation, it's the upper limit minus the lower limit plus 1. Here, 7 minus 0 plus 1 is there's 8 terms here. Now I plug in. When I plug in, I keep everything as fractions, and I'm going to type the numerator into my calculator and the denominator into my calculator separately to see what I get. If I did this correctly, what you should have gotten here is in the numerator you should have got 255 divided by 256, and the denominator 1.5. If your calculator is giving you a decimal, what you can do is use the fraction to decimal button to convert back and forth. Now I'll take care of this division here, 255 over 256 divided by 1.5, multiply by 12, and my final solution here is that the sum of this geometric series is 255 over 32. I hope this video helped you figure out how to find the sum of a geometric series. Thanks for tuning in. I'll see you next time.